Hi guys, welcome to another tutorial of MySQL database administration. Today we will be talking about another high availability solution that is provided from MySQL. It's MySQL InnoDB Cluster. In this tutorial we will be talking about InnoDB cluster introduction, that what is the architecture and how what are the components combined together creates MySQL InnoDB cluster. Guys, if you haven't subscribed to the channel, please subscribe, and please like this video and share with other friends. Before we have discussed another HS solution which is called InnoDB replica set. If you haven't watched that, please go back and watch our InnoDB replica set tutorial as well. So let's start with this tutorial, and this is how our this is overview of MySQL architecture. We have MySQL Shell as an admin cluster, and MySQL Router for load balancing, and this is where the MySQL server resides, and it's called HA cluster. And internally they have is group replication. So MySQL InnoDB cluster based on group replication. It's not an asynchronous replication, just like replica set. Replica set have asynchronous replication, and this one have is group replication, which this is why it provides us failover like automatic failures. So this part is called this area is called MySQL server HA cluster, and this is where everything is happening. It's built in on MySQL group replication and provides feature as automatic member management, fault tolerance, automatic failure, and so on. And InnoDB cluster usually run in single primary mode, but with one primary read write and multiple secondary instances. This is primary instance which will be used for read write, and these two are secondary instances. You can have other more secondary instances as well for read and read and write. So read only, and we have read write for primary instance, but you can also have multiple primary instances as well, but it's better to have only one primary for read write and the other two for read only purposes. And then the next part we have is MySQL Shell. It's used for cluster administration. It's an advanced client and co-reader for MySQL. Can be used because it provides multiple modes like JavaScript and Python and SQL mode as well. So this can be used for your any kind of DevOps scripting and some other automation if you want to do. You work with InnoDB cluster using this admin API. MySQL Shell provide admin API, and it is provided as a part of MySQL Shell. So what admin API is provided in JavaScript and Python, and is well suited for scripting and automation of development of MySQL to achieve high availability and scalability. By using MySQL Shell admin API, you can avoid the need to configure many instances manually. So before, when you supposed to create any MySQL group application or any MySQL InnoDB cluster, what you have to do is that before adding the instance, you have to transfer all the data to that instance, and then you can add this instance to MySQL cluster. But with MySQL admin API, which is come with MySQL Shell, it provides a clone plugin, and the clone plugin, what you will need to do is that you call an object add instance, and it will clone your current source server to the target servers, and that's it. It will do everything automatically, and the speed depend on how much data you have. But it's a physical replica. It creates a physical replica, but which is very fast and consistent replica. So this was about the MySQL Shell. And then we have a MySQL Router. It's a lightweight middleware that provides transparent routing between your application and the backend MySQL server. Actually, it's a load balancer, so it can be used for a wide variety of use cases, such as providing high availability and scalability by effectively routing database traffic to appropriate backend MySQL server. So that's so this MySQL server, MySQL Shell, and then MySQL, all the servers combined together. Sorry, the last one is MySQL Router, and combined together in this picture, MySQL Shell, MySQL Router, and my primary instance as well. You can do any other MySQL connectors, like if you want to connect from MySQL Yog or MySQL Workbench, so any other application client can connect to this MySQL Router, or MySQL Shell can be also used for any if you are coming from the host as well. And MySQL Shell use the MySQL X protocol admin API to connect with your MySQL cluster. So this is all about MySQL introduction, and now next we will be configuring or installing our MySQL cluster in practical. So keep on with me and let's see how it's done. Okay guys, so next now we will be installing our MySQL InnoDB cluster, but for this we will be using our Docker images, and we will be running around 5 Docker images, 3 for MySQL servers and 1 for MySQL router, and the other one we are running will be for MySQL client, so we can check how we will be interacting with the MySQL InnoDB cluster. And don't hesitate, this is very easy, and I'm using Docker because most of the people don't have this high potential PCs, so they can run 4 or 5 VMs. So stick with me, we will doing it with Docker, and this is very easy tutorial, and this is gonna help you a lot to learn how this MySQL InnoDB cluster work in practical, and it's a lot easier to run on VMs. So all you need is a VM, and your VM should be able to ping to the internet, so we can download all our Docker images live, and I will be doing the installation of Docker, and then I will be pulling Docker images and then running the Docker images. Everything will be very simple, neat and clean. So for this, if you want for this, you just need to follow up with me, and please subscribe the channel, like, share and share with other, and so we can grow up the community. So let's start with the Docker, and to install the Docker, you can go to here, docker.com engine install, and you can come to here to CentOS. Okay, and you can do it from here using the yum repositories as well, Docker engines, and but like here setup repository otherwise, but I'll be doing using the curl script. Docker provide this, you can come here, get.docker.com, and all you need is to this script is meant to be quick and easy install via this. Okay, so all you need to copy this here and run this on your VM machine. So once this is done, you will see here this get docker shell script. All you need to do is sh this, and it will download, install everything for you, the latest version, and then after that all you need is to run your Docker. I will pause the video here, and so once this is done, I will continue our video again. Okay, so now if you see here, our Docker has been installed, and if you see the Docker version, we have to 20.10.10, and it's running now. So then after, what you need is to just start your Docker, and that is for system ctl start Docker. So now our Docker has been started, and you can check the status as well. So it's running, active and running. And now all you need is to because to run your MySQL InnoDB cluster, you need a network. So Docker need a network to run different, so they can communicate with each other. So I'm not going into details of Docker, how the network works and how things work, like I'm not here to teach the Docker, but I'm here to teach you how we can deploy our InnoDB cluster using Docker. So in order to do that, first you need a network for that, and we are going to create a Docker network called as InnoDB net, and that is let me clear the screen first. So now our network has been created, and let's create some of our Docker containers. Okay, so what this is gonna do is docker run and manage daemon and detached mode. This provide a name like MySQL 1, MySQL 2, MySQL 3, then host for name like MySQL 1, MySQL 2, and then the network we are going to use is this one, which we already created here. And after that, what we are going to provide here is MySQL root password. This password could be anything. If you check, go to this MySQL hub, and you see here this documentation of MySQL Docker official image, and what is MySQL after that, and how to use this image. You can say that you can provide MySQL root password and any password, and you can provide any name. Okay, so if you see here is the password to be set for the MySQL root, and this is all. You can, if you want to know how to use this image further, you can do it here. But if you want to learn, if you want a new tutorial about how using MySQL Docker images, let me know in the comment section, and I will come up with another tutorial regarding the using MySQL inside Docker container. Okay, so now what I'm doing here is I'm going for a MySQL image. This is a tag that I want 8.0, and this will download our image. So if the image is not available here, then it will download it online. Like if I say here Docker images, so currently I don't have any image available, so obviously it's gonna go to the internet and download it itself, and then it will create automatically, because I'm going a for loop, and it will create few 3 of our Docker container. Okay, so once the images, first we have a Docker images, then when the image is running, it's called a Docker container, and the image is basically just like if you take it as a file system, it's a bunch of folders, just to make it easy for you guys. But so let's do it. So now you say is it unable to find the image locally. Now it's going to pull from the MySQL server, and it's going to download it. So obviously my internet speed is not that good, so I will pause the video here as well, and once this is done, I will come back and let you know that what's happening. Okay, so now if you see here, our Docker image has been completed. Poll has been completed for all of the Docker images. If you see here now, if I say Docker images, we must have one of our so we have now is a MySQL server image here, which is around 405 MB. Now to see if your Docker images has been running or not, what you can do is Docker process -a, and then it will show you that what's the condition of your Docker images. So if you see here, it's been running up from less than a minute here, and it's running on all the servers, or the MySQL server is running on 3306 by default port. We are not changing any default port, so it's just to tell you that how you can check. So you don't do anything until you see here, because it takes around 30 to 35 seconds to become your Docker container comes in a healthy state. So you will see a starting stage here. So once this is healthy, then after that you can continue what you want to do. Okay, so next step is we are going to create our users, which is inside all of these 3. Okay, so now it's done. What we have done here is I've just did that create a user, cluster admin identified by admin, and then I granted all the privileges with the grant option, and then what I did is I executed a reset master on each and every one. So there is to make it a clean, and if you want to know that my user are created or not, what I'm doing here is going inside this Docker and interactive mode, and I'm telling you execute MySQL 1 and then MySQL -u cluster admin -p admin, and it's gonna give me that we have in MySQL 1 we have cluster admin, in MySQL 2 we also have a cluster admin, and MySQL 3 we have a cluster admin user. So this is what we have done till now, and now next we need is to configure our MySQL instances ready for our MySQL InnoDB cluster. So before we create InnoDB cluster, we need to make sure that your MySQL server is ready to be added inside your MySQL InnoDB cluster. Okay, so in order to do that, what I'm doing here is that we need to go to inside our one of our MySQL MySQL Docker image, and what I'm doing here is the MySQL go into interactive mode, and I'm launching here is MySQL Shell with the user root which we provided when we here you see here when I launched our MySQL image here. Just a minute before Docker. Here you see here I gave him the password root, and the user is obviously root. So now I'm going here in MySQL Shell, use the MySQL Shell and use this socket to log into MySQL Shell. So now we are here in MySQL Shell, and if you check here, let's go to SQL mode and select it host name. So okay, how's that possible? Okay, currently I haven't logged into MySQL or MySQL Shell, that's why it's not currently haven't logged into any MySQL, so that's why I guess it's not giving me the correct host name. Okay, the issue is it should be like this. Yeah, so this is MySQL 1 host name. I haven't logged into the MySQL 1 just to show you that where I am. I think this should believe MySQL Shell allow. I don't know why it does not allow, but I will see. Okay, so we cannot clear the screen from SQL prompt. Let's go to shift to our JavaScript again, and let's run. Let's check if our instance is configured or not. So before let's see. So if you see here, our password was admin for the cluster admin before we user created, and if you see here when I check that my admin check instance configuration for MySQL 1 running on the port 3306. So let's see if this is like ready to be configured for InnoDB cluster. Then it says that checking instance, saying that checking instance configuration, some configuration option need to be fixed, which is like enforce GDID consistency, it should be on, and GDID mode and server ID is current value is 1, but we need a unique ID. So we need to update all these things. So status is error. So in order to do that, obviously it will be the same for the rest. If I do it for MySQL 2 as well, user provide admin, so it will be same for each of one. So MySQL 2 and MySQL 3 as well. You can check that for the MySQL 3 as well and let me know in the comment so it work for you or not. And then now we need to do is configure. Okay, so DBA dot its DBA is an object. Further we have some functions to use, and DBA dot configure instance for MySQL 1, and it says that provide the password and provide the password. Now it's saying that do you want to perform the required changes? So obviously we want that in order to configure our instance for to be ready for addition of MySQL cluster InnoDB cluster. So we say yes. Restart the instance after configuration, we say yes, you can restart it. Okay, so it says that your it was restarted, and now we are back here because our if you see here our docker ps -a exited few it's gonna exit because it restarted it. So that's why now we need to bring back. So we say that docker start this one, we need to start it. So once this is ready, see it's starting again. So once this is ready, we will be able to log in into we will continue the next step. So it's still like starting. It will take around 40 seconds. Still okay, so now it's in healthy state, and let's go back and log in into our MySQL Shell. And okay, so now we are here, and if you see, if I check our instance configuration like here, because we have configured our instance, and it should say that yes, now your status is okay. So before it was error and now its status is okay. And let's do our configuration for the rest from here and provide admin. Okay, and yes, and yes. It will restart that as well and will come back by itself. Okay, DBA.configuration for the MySQL 3 as well. Provide the admin password and let's say yes, yes. Okay, now let's see what are the conditions. So they are here and they have exited, and we need to start them as well. Docker, I guess they should come back by itself. Okay, so if they are not coming back, you can manually start them. Docker start. Okay, and this is my container ID, and now we should be coming in starting mode. And let's start the first one as well. Okay, so now if you see here, they are in starting mode. Let's let them get started. So once they are in healthy state, then we can check that they are ready for our MySQL instance configuration or not. Okay, the second one is ready. Let's wait a 10-second more, so the next one will also come back. And yeah, so now all of them are in healthy state, and let's see what's the condition of our these two. Okay, so let's check this one as well and provide the password admin, and it's ready. Okay, and when we check the last one, provide the password admin, and now it's ready as well. So now we can see that our cluster, or 3 of the servers, are ready to be installed, like to be configured in our InnoDB cluster. So then we need is what we need here is to what do you say, let we already have restarted our Docker, but we don't need it right now, so we are already here. So you can restart it in case you want, but I guess we don't need it here because we already know everything is working fine for us. So let's go to now we are already here inside our MySQL shell. So because if you go for restart, then you need to connect back to your server. So let's connect to our MySQL cluster admin, to MySQL 1, and provide the password. So now I'm connected to MySQL 1. Before I wasn't connected. If you see here, I just to localhost, and I was connected to shell, so I wasn't connected to any MySQL server. I'm connected to MySQL server 1, and at the port of 3301, and using the SSL for the secure connections. Okay, so now what we need here is to create our cluster. Going to create a cluster. So it's adding the seeds instances, and so once this is done, if you see here, it's saying that cluster successfully created. Use cluster.add instance to add MySQL instance, and you need at least 3. So that's for sure. You need at least 3 servers to be having a good topology. So now if you see here the cluster status, and if you see the describe, you can use the describe as well. So cluster is saying that I am the primary. Okay, MySQL 1 is the primary, and no tolerance. We don't have any tolerance for now. And port address mode, it's a read-write mode, obviously, because it's the primary one online, and this is the version. So you see the describe, it can tell you that it's a default name, and this is a role as change single primary mode topology. Single primary mode, you can have multiple primary as well, but for this tutorial I will be only giving you how to configure the InnoDB cluster and do some testing for the failed tolerance. We will be going into deep dive in the further sessions. Okay, so now this is done. Now we will what we need is to do is the cls.add instance. Okay, what about this cls dot means that what I have done here is that here I created a variable and called our object to cluster. Okay, so now we can do anything in this because this cluster cls dot have a few like if I see that cls dot, so there are a lot of functions now we can call, but currently the function we need here is cls dot add instance. So this cls can be any variable, because it's just a variable. You can do any variable you want to name it. Like you can instead of cls you can say that cluster, instead of cls you say my cluster, my variable, or Maurice or something, anything you want to do. So we are using the cls dot add instance, and then provide the password admin, and you can use the clone, incremental, abort, but I will use incremental because I know currently nothing is happening over my SQL server, and all the GTIDs will be transferred to the other server. So I'm using this incremental mode, and it will also not restart my SQL server. If you go for the clone, it will also restart your server, and you have to manually restart your Docker image as well. So you can let me know once you do the I will encourage you to use the clone, just enter here by default would use the clone plugin, and let me know that what happened, and if you face any issues, let me know in the comment. I will solve them for you. And now let's add our second one. Before that, if I tell you show the status, you will see here that we have another server, MySQL 2, and it's online as well, and it's a secondary. Okay, it's not a primary, because the primary we have here is MySQL 1 only. So now let's add the third one, MySQL 3 here, and provide the password here as well, and say I incremental, and you see here this has been added into, if you see here the status, and let's describe. You see here single primary vault, our this is a topology we have here is MySQL 1, MySQL 2, and MySQL 3. These are the three we have, and if you see here the cluster images, cluster is online and can tolerate up to one failure. Before we had, if you come here, cluster is not tolerant to any failure. Okay, and once we had only one, you see, so once you add three servers here, then only your status text will be cluster is online and can tolerate up to one failure. So you must have any one server. So let's add another in case so this is done for now. Our cluster is ready, and in case you want to add another Docker image, what you can do here is let's say I want to do is MySQL Docker image. Let me copy this. Okay, and it's nothing but just a simple script we have, and let's say okay, I want to do is MySQL 4. We already have 2, 3, and 4 we have, and you want to create another Docker image, and it will start your Docker image, another one. So if you see here ps-a, the fourth Docker image is coming live, and it's in healthy state. It's gonna be in healthy state. So this is what I have shown you, that how you can do a Docker. You can launch another Docker image using this script, and after this you guys please add this into your instance, what you need. Okay, so I think I should do it for you as well. Okay, so here so you guys do it and let me know that how you can do it. So if you face any issues, I will do it for you. All you need to do is run some queries inside, and it will do the job for you. It's not that big deal to do that. What you need is to copy this part, okay, first, and just change this to MySQL 1. Okay, let me do it for you guys. Okay, sorry, not 1, we need is 4. First I need to check if this has arrived or not. Okay, it's in healthy state, and let's do this. Yeah, MySQL 4. this is sure. Okay. This here is the issue. MySQL 4. I was doing some wrong setting. So if you see here, everything is done. If I want to know that it has created the user or not, I'll do here is MySQL 4 and check the cluster admin has been created or not. If you see here in MySQL 4 we have the cluster admin created, and this is how you can do it. And let me configure it for you guys as well, and let me copy this here for MySQL 4 as well. And let's go here and tell him that configure instance. It will ask for the password. We provide the password, we say yes and yes, and it was restarted. And if you see here, ps-a exited, and we say docker start. This is our okay. So now once this is ready, we will add this into the cluster. I'm doing this just to tell you that how we can do it for if you want to add another instance into your MySQL cluster. Around 30 seconds it take to start. So once this is ready, I will be patient, guys. Okay, now it's ready. Our fourth MySQL 4 is ready now here. Okay, so let's add this into our MySQL shell, sorry, MySQL cluster. Use 4 here. Okay, and come here to the and say admin, and we say I clone, and yes, what this is going to do is it will add, so it's been added now. If I say describe, so we have another MySQL 4 inside this, and if I say cluster.status, we will see here that we have another MySQL 4, and it's online and it's in read-only mode, because three will be, because only one will have in read-write mode in a single primary mode, because we have only one. So one instance will be read-write and the other rest of them will be read-only. Okay, so now what we have talked in our presentation here is that now this part is done. MySQL servers, the primary and the secondary nodes is done. Now what we need here is for the load balancing we need a MySQL router. So we will create another Docker image and we will be installing and we will tell them that we will need a router Docker image, and we will tell them that to come up and act as a MySQL router. So in order to do that, now we will do is docker run the detach mode, and name is MySQL router, and use the same network, and we are providing him the host and telling him that get bootstrapped this host, use this, and we will provide the password here, cluster admin. This is our cluster admin, and this is going to be our password. So this is we were saying him that you have MySQL members you have is 4, or you can use whatever number of user you want to have. Is like if you have 3 members in your topology, you will use 3, or your 4 you will use 4. So now let's do this. Let me come here, and so obviously because the image is not available here, because server is already here, it says already here, but I need a MySQL router docker image, so he will download it, and it will download it, and then it will start it. So once this is done, I will come back. Till that I will pause the video. Now if you see here, our pull has been completed, our extraction has been completed, and everything is almost completed. And you see here now docker ps-a, it's going to come back, starting up the MySQL router docker image is going to start up. So once this is up, we will I will tell you that what everything has been done in the background, but actually it will do that, it will do all the bootstrapping, because in this command we have given everything to him, that we are bootstrapping him. MySQL 1, MySQL, everything is provided here. So now you see here it's in healthy state, and this is up and running. So in order to check what is have done, we will telling him that Docker, we need to see the logs of MySQL router and show me what is have done. What it did has that okay, from here it has, this is the MySQL inside, this is a template, this is a location where it has stored the configuration of MySQL router, and these are the port which will be used for read and write and read only. 6446 is going to be for the read write, and 6447 is going to be for read only. So this is how we will be using our router, and let's do it. And now let me run Docker client Docker through which I will be connecting to my SQL router, and then that router will be pointing out to our cluster. So now this is come because let's get started. Once this MySQL client Docker image is running, it will take 30 seconds. And so once this is running, we will use this Docker image, our client image, to connect to our MySQL router through, and then it will connect to MySQL servers. So if you see the image here, now what I'm doing here is that I'm getting this client application, okay, MySQL connector, and it will come here to MySQL router, and then this sub router, because this part is done now, this area. Okay, so this area is done, this area is done, and now this is coming up. So then we will connect to this, and this area is already configured that MySQL router is connected to MySQL servers. So I guess it will be up and running. So yes, so our router MySQL client is also running, and let's do what is required next. Okay, so what I'm doing here is that Docker execute in interactive mode, go MySQL client 1, okay, then MySQL Edge, MySQL router, okay, and use the 6446 port, which I've already shown that this one is for read write, and then use this user password and execute few statements, and let's see that it's gonna work or not. So what I have done here is that let me show you here that select host name, and you see here select host name coming here, and then create a database, okay, then use that school database, create table if not exist student, and do some like this creating table, then inserting some values like student name and all that. One is Aslam, one is Ahmad, and I think the other one is here Mughis. So we have three values, Aslam, Mughis and Ahmad, and you can see here that Aslam, Mughis and Ahmad. If you still want to know what if it is created or not, so you see here we have created, okay. So what I have done here is that I went to MySQL router and told him to connect to this one. So once it will automatically go for MySQL 1, because only the read write available here is MySQL 1. So because you see here it's connected to MySQL 1, when we went to this connection, we went to use this we went to use this MySQL router and giving him a port to 6446, and it connected to MySQL 1, okay, because the only read write instance we have here is MySQL 1, okay. And if I go here and let's say let me add another one here, just like this, MySQL E here, sorry, let's say I want to select hostname like this, and I want to execute here another statement, okay. So if I execute this again, you see here it's went to MySQL 3, okay, because what I'm doing here is I'm going for the select, okay. So that's because, and I'm going here is for 6447. So when I'm going for 6447, that here you see here 6447 is for read only, and 6446 is for write and read and write, okay. So if I execute this statement again, let me copy that again, and I will tell you that it will go for because it's in Robin Hood, so it will rotate. Okay, so it's rotating and it's went for the MySQL 4, and if I go again, it will go for MySQL 2. Okay, so 2, 3, 4 and then 2. So it's in because we are going for the read only, so all the read statement are done in round robin mode, and so this is how the MySQL router work. Okay, so this was to tell you that how things work, and let's connect again. Let me check what is current scenario. Let's say cls.status. Sorry. So if you see here, we have 4, and our current primary is which one? Primary, yeah, MySQL 1 is our current primary, and we have the rest of them are like our secondary and read only. So what now we will check the fault tolerance, and what I'm going to do is that stop our MySQL 1, which is the primary. You see here, primary is MySQL 1, and we will going to stop it. Stop MySQL 1, and once this is stopped, we will see that how our MySQL is going to redirect. So if you see here, MySQL ps-1, yeah, you see here MySQL 1, it's exited 2 seconds ago, so it's now stopped, it's not running. Okay, and let's check our because you see here, it came out of MySQL 1 because MySQL is not running anymore. So if you enter here, you see here it's automatically came out, and now what we need to do is to start connect to our MySQL through our router. Okay, and now we will connect to MySQL router because, and let's see where it's gonna connect, and we are going for the 6447, which is a read write mode. And now if I see here, let's get my cluster, because the name is of my cluster is my cluster, and then cls.status. If you see here, it's saying that MySQL 1, it's missing because we stopped the MySQL, and now the primary is MySQL 4. So it's automatic, it's just went on and just selected any primary it wanted to select it. So you can configure this that which should be your next favorite, like if MySQL 1 went down, you can also select which one should be your next primary in case MySQL 1 is not there. It's randomly connected, but you can add tags to this, and you can tell him that this should be my next favorite primary. We are not going that, we will do it in the next tutorial. This already have become so long, but okay. So now you see here, this one is missing, and let's start my MySQL 1 again, and let's see how is MySQL 1 going to be added and how it's going to be redirect. So you see here, this is in starting mode, and if I see here the status, I still you see here it's online and everything is perfect, and just come back. And before coming online, what it does, that it's tell you that it's only what it does, that it's first come in recovery mode, and then it's become online, and all the replication is carried out to the first server. So this is how it's done. This is how things work for you. So okay guys, and in order to check that it's working fine as well, everything should be working fine, and so this is how you configure your MySQL InnoDB cluster. If you have any question, if you do not understand anything, you can ping me anytime on our WhatsApp group, or you can send me in the comment as well. I will reply as soon as possible unless I don't get the notification. So thank you guys for watching this tutorial. Please stay connected and learn more from me, whatever I have learned. And thank you so much.